Hi guys, you met me earlier from the panel, so I won't spend a lot of time introducing myself. I'll just go through an algorithm that is a component that is utilized in a decentralized setting. It's called the Crypto-Hbga. It's an algorithm that we coined together in a joint venture that we formed with a company called Mind.AI, and we ended up with a company called Mind.OT. So first I'm going to explain certain elements of that algorithm and what makes it work, what makes it effective. So what's cryptoeconomics? How many of you are familiar with cryptoeconomics? Please raise your hand. Okay, so for the rest of you, with the cryptoeconomics is we basically use cryptography to ensure certain elements that they did happen, and economics to incentivize components to happen in a certain way. So if you want to make money, you make the system better. If you want to make the system worse, you end up losing money, and there is no escape from it. And that is the basically fundamental element currently with Bitcoin. So the way it would work, each and every miner is incentivized to get something called the hash, which is part of the proof of work, but that's not necessarily the only thing that can make it work. In the future, we will see different elements of proof of work, but it's basically machines competing to find that number. And that's how you can get autonomous machine running on its own. So zooming in here, we will see that there's some elements that are in that thing in green. I'm going to describe that a little later, cryptography, and how is the money being provided. In machine learning, there is an algorithm called the genetic algorithm. It's been utilized for over 30 years now. What is the GA? How many of you are familiar with genetic algorithm? Please raise your hand. Great. Okay, so it's inspired basically by the process of natural selection that belongs to the larger class of evolutionary algorithm and so on and so forth. So it was first coined by John Holland, but then it was evolved over time by Goldberg and so on and so forth. So IEC is interactive evolutionary computation, GA is genetic algorithm, and Hbga stands for human-based genetic algorithm. So some GAs that you would find out there, I won't go through each and every one of them, but they're used for specific things like neuroevolution or particle swarm optimization. They're proven algorithms that they serve certain aspects. Now, when we look at Hbga simplified, in the traditional genetic algorithm, which I should probably cover that. So genetic algorithm uses the machine as a processor, the human as another machine as an innovator, another machine as the actual validator. But the human-based genetic algorithm continues to use the machine as a processor. But what if the human is the innovator? And then what if the other human is the actual validator? And as it's going through that cycle, you're able to get certain things to get better over time through each and every generation. Now, where is the data coming from? Mobile devices sitting in your pockets. You can get data implicitly or explicitly. Implicitly is very powerful when you do spend a certain time on a certain article or share an article with somebody. And that got us to build a meritocratic human-based genetic algorithm. So that's the GA simplified, and then we get to transform, the Hbga simplified, We get the human to be the innovator, validator. And then you have the Hbga that is meritocratic, and what it means, instead of the democratic, For example, if you have 8 people, they think that a certain thing is good. You know, for example, a car, but then 2 people, they think it's not. In a democratic model, you assume that it's good. With a meritocratic, would ask the further question, what if those 2 people, they know a lot about mechanics, maybe you need to trust them a little bit more than the 8 people. And that was built about 11 years ago, and I was involved in that research deeply and worked in several companies. One of the companies ended up to become an Intel company. So that's history, okay? Now, what we are working on towards the future, this is one element of maybe 17 different elements that are necessary. On its own, it's not sufficient, but it's necessary. It's being used in Mind.AI to build the ontology. How can you build the ontology in a decentralized setting without having anyone to say this is right or wrong? When folks have an incentive to make money to put in certain innovation into the ontology, they are likely to do it right, and if they don't, they end up losing money. Now that money, if it's a centralized, entity that it can, in any decentralized setting, the moment you introduce a single centralized point, it defeats the whole purpose. In cryptography, there's something that we say you're as good as your weakest point. In decentralized setting, you're as good as your centralized point. So when you have a process that is actually running autonomously, and as people they make more money, they make the system better by innovating, and the validator is the same thing. And that keeps going over and over without necessarily having a lot of data. So that is unprecedented, okay? If we get to the how, I'm going to spend a couple minutes on the how. So this algorithm sits on binary structure that is called the Toda-Tree. That binary structure is a huge binary tree that has 256 levels. It's an imaginary tree, the imagination of computers, you might think. It will never be created because on level 160, you can have more points in it than estimated atoms in the universe. However, when you take certain branches of that tree and then enhancing the actual ontology you build in that tree, yet you know the provenance of where it's coming from devices that are also on that tree, it goes down to the actual packet level, the network packet level, to have something of value that is being transmitted from one user to the next and so on and so forth, and as it's evolving. With that, you're able to run it in a fully decentralized setting while having some redundancy. And that redundancy is X32. Why do you need redundancy? Because if you're running it in a decentralized setting, your device might be off and the system is dependent on it, but then there's 31 other devices they're on, and so on and so forth. So with that, it just concludes my talk. I kind of condense it, it's just a 10-minute. I just want to make sure that if any one of you has any questions, this is a component that is essential in decentralized setting to building the ontology. Like I said, it's a necessary step, but it's not sufficient. Thank you very much.
Well, next up you have myself, and just a very brief talk before we bring